This is Emily. Emily is an active woman. She is a lawyer at the prestigious John & Johnson company. Beside her career, she has a husband, 2 daughters and 3 grandchildren. Today she turns 63 and she's feeling healthy. However, like most people her age, she takes several medications a day. One for cholesterol, another to reduce arterial hypertension, and a 3rd one for menopause. She has been taking daily doses of these for many years now, but for a couple of months now she has had back pain. Her GP diagnosed onset of arthritis, meaning adding another drug to her prescription. Since she started taking the new anti-inflammatory medication, she's experiencing chronic headaches. But headaches are not listed as a known side effect of this drug. To understand what is going on, let's take a step back for a minute. Every morning, Emily starts by taking the hypertension medication. So far, so good. But when combined with the new anti-inflammatory drug, she starts to feel pain in her head. In fact, drugs can interact with each other in our body, for instance, when they go through the liver. Drugs are broken down into smaller compounds called metabolites. Those metabolites can interact with proteins or other metabolites and can cause unexpected adverse side effects. Currently, more than 1,600 FDA-approved drugs are available on the market. This means there are more than 1,200,000 possible combinations between 2 drugs. That's a lot, even for researchers, and especially when they are developing a new drug. The time and resources required to test all of these combinations would be just too much. For all these reasons, we created BioXagon. BioXagon uses cutting-edge artificial intelligence methods to predict side effects caused by drug interaction. Let's have a closer look. By combining large biological and pharmaceutical databases, we have modeled the metabolization of each drug in the human body onto a graph. Drugs are broken down into a series of metabolites and interact with proteins. Interaction networks between metabolites and proteins form the links between the nodes on the graph, allowing us to plot multiple drugs in the same graph and predict the potential side effects. The resulting graph showing all the drug-to-drug interactions is huge. Each node is represented by a unique set of values called a feature vector. We use a graph convolutional network to project feature vectors into a more abstract and compact representation of each node. The idea is to compute self-embedded feature vectors by favoring links between neighbors. Multiple rounds of convolution are consecutively applied to define this transformation. This process is called encoding. When 2 encoded vectors representing 2 drugs are combined, the AI can predict the probability of side effects between the 2 drugs represented. The estimation of side effects probabilities is called decoding. Let's sum up. First, the encoding, then the decoding. This encoding-decoding step incorporates many parameters to optimize the transformation. The algorithm seeks the best combination using prior knowledge to obtain the optimal transformation. This step is the training. With BioXagon, pharmaceutical companies will soon have a new, efficient tool to predict side effects resulting from drug interaction of new medications with existing ones on the market, thus helping better drug selection at early development stages. Of course, Emily will forget about her headaches, as well as 88% of Europeans over 65 taking at least 2 drugs per day.